Okay, so in this video, it is actually the last video for this unit. We're going to talk about different types of triangles as well as angle side theorems. So first of all, let's practice classifying triangles by both its angles and by its side lengths. So this very first one is by their angle measures. Okay, so an acute triangle is a triangle that has all angles less than 90 degrees. So let's go ahead and draw a picture. And it'd all be less than 90 degrees. So we could say 60 and then 40 and 80. So notice that all angles are acute, which is why it's called an acute triangle. Okay. A right triangle is a triangle that has one angle with a measure of 90 degrees. And that actually means its other two angles are going to be acute. So both of these will be acute. Think about why. The two have to add up to 90. So in order to add up to 90, they both need to be less than 90. An obtuse triangle is a triangle whose measure is one of its angles is greater than 90 but less than 180. So for example, 120 and 20 degrees and 40 degrees. Remember that a triangle adds up to 180 degrees. And then lastly, an equiangular, fun word to say, is a triangle where all three angles have the same measure. So in order for that to happen, 180 divided by 3 gives me 60. So each one of these angles needs to be 60 degrees. Why? Because all three angles need to be the same. Okay, the next thing we're going to do is we are going to discuss side lengths, how to classify a triangle by its side lengths. So a scalene triangle is a triangle whose sides are all different measures. So 9, 8, and 7. All those are different measures. A triangle that has two congruent sides is known as an isosceles triangle. So 10, 10, and 5. Notice that two sides are the same. And then an equilateral is very similar to the equiangular, but this time it's the side lengths that are all the same. So 5, 5, and 5. Okay. And then a couple things we need to know about a triangle that's an isosceles triangle is that the base angle in this example is the ones that are opposite of the legs. So here's my base, okay? Here's my legs, these are opposite, here are the base angles. So in this example, it would be angle B and angle C, and they are opposite the congruent sides. Okay. How did I know which ones were opposite? Well, these side lengths are congruent. How do we know? Because they're marked that way. And then the sides opposite them are considered the base angles. The vertex angle in this example is angle A, and it is opposite of the base. So here's my base side. Opposite is the vertex angle. The base is the non-congruent side, and the legs are the two congruent sides. Okay, the first thing we're going to do is we're just going to practice classifying by these sides and these angles. So the sides, notice that these two are marked congruent. Okay, but the third side is not. So this is an isosceles triangle. And then if you look at the angle measures, all of them are less than 90 degrees. So this would be acute. In our next example, again, the two sides are congruent. We're missing the third side, 90 degrees. So we have an isosceles triangle again. And this would be a right triangle. How do we know? Because there's a right angle. Okay. In the third example, we're missing some information here, but I'm just going to go ahead and give you different sides. So this is going to be scalene because all the sides are different. And then you have one angle bigger than 90 but less than 180, so this is obtuse. All right, let's go ahead and look at 12. Notice that all these marks means that all the sides are congruent. So sides are going to be equilateral. And then all these arcs mean the angles are going to be congruent. So equiangular. And something that we're actually going to learn in a little bit is that if a triangle is equilateral, it'll always be equiangular or vice versa. And then let's go ahead and do the last one. So we have the angles are acute, and then you might say, well, this one is actually missing information for the 2 on the sides, but it's not, because notice that all the sides are different. So all the angles are different. So if all the angles measures are different, that means all the sides are going to be different. So this is scalene. I'll say that again. If all the angles are different, that means all the sides are going to be different. And then we are actually going to save this proof for class. So I'm going to do this proof together. Okay, and that sums up our types of triangles lesson. So let's go ahead and go to the next one, which is the angle side theorems. So if isosceles, then at least 2 sides are congruent. Then the converse of that is if at least 2 sides congruent of a triangle then isosceles. Okay. And then based on the angles, if isosceles, then at least 2 angles are congruent, we're going to do the same thing. So if at least 2 angles congruent of a triangle, then it is an isosceles triangle. Okay, so we're going to jump in right away and do a proof. So first of all, it says MJ is an altitude, which we are going to have to break down. What information does that tell us? And MJ bisects angle KMH. Again, we're going to have to break that down and let us know what it tells us. So in order to prove that this triangle is isosceles, HMK, which is the big triangle, we need to prove that at least 2 sides or 2 angles are congruent. Well, hopefully with this whole congruency pattern, you are picking up on the fact that we are going to have to prove the triangle is congruent first. So in order to do that, let's go ahead and break down some information. So it says that MJ is an altitude. Well, if MJ is an altitude, then that means angle MJH and angle MJK are right angles. And the reason is because if altitude, then it forms right angles with the opposite side. Okay, that is just the definition of altitude. So now that I proved that, I'm going to go ahead and mark it. Okay. And what do we know about right angles? We know that they are congruent. So we can say that angle MJH is congruent to angle MJK because right angles are congruent. Okay, so we proved one congruency. Now we also need to break down the fact that MJ bisects KMH. Well, what do we know about an angle bisector? It divides an angle into two congruent parts. So KMH, that means that these two are congruent. So angle HMJ is congruent to KMJ. That's the definition of an angle bisector. Okay, so now we have two components. We need a third one. A third one would notice that they are sharing a common side. So we would say MJ is congruent to MJ by the reflexive property. So I'm going to go ahead and mark that. Now do I have three components to prove that the triangles are congruent? I do. So triangle HMJ is congruent to triangle KMJ. And the reason being would be ASA. And the steps to get there was 1, so 3, 5, 4. Okay, so I am definitely running out of room on this proof. But remember that the whole point is we're trying to prove HMK is isosceles. So we need to either prove that two angles or two sides are congruent. It doesn't matter which one I do in this problem. I can say either the two sides are congruent or I can say that the two angles are congruent. I'm just going to do that HM is congruent to KM. And the reason being is CPCTC. So corresponding parts of congruent triangles are congruent. Now that I proved two sides were congruent, I can say that HMK is an isosceles triangle. And I'm going to go ahead and zoom in on this so I can actually write. Sorry that I ran out of room. So step 8 would be that triangle HMK is isosceles. That's okay. And the reason being is if at least two sides congruent, then it is an isosceles triangle. If you would have said two angles congruent, so let's say you said angle H is congruent to angle K, that's fine, but then you would have to say if at least two angles congruent, then it is an isosceles triangle. Okay, those are the only two ways you could have proved that problem. All right, let's go on. That was a pretty long proof. The angle side theorems, basically if two sides are congruent, then the angles opposite them are congruent. And the shorthand version is that if two sides congruent, then the angles opposite them are also congruent. That's the shorthand version. Okay, so if two sides are congruent, then that means the angles opposite them are also congruent. And then we can do the converse. If two angles are congruent, then the sides opposite them are congruent. So if two angles congruent, then sides congruent. So in this example, we would know that the angles are congruent, therefore the sides are congruent. Okay, based off this information, let's go ahead and algebraic problem. So first of all, notice that we have vertical angles. Remember that vertical angles are congruent. So if the right side is 2x, then that means the left side is 2x. Then notice that we have two sides of a triangle congruent. So that means the sides opposite them are also congruent. So this is 5x. And what do we know about the triangle? A triangle adds up to 180 degrees. So 5x plus 2x equals 180. and we get x to equal 15. Okay. All right, so let's apply those angle-side theorems to a fairly short proof. We know that DE is congruent to DH, so DE is congruent to DH, and we know that EF is congruent to HG. Prove that DF is congruent to DG. Okay, so first of all, remember that this whole chapter is about proving triangles congruent, so we should probably aim for that. So we need to prove that these two triangles, DEF and DHG, are congruent, because if we can prove that, then we can say these two sides are congruent because of CPCTC. So using our angle side theorems, if two sides are congruent, then that means that the angles opposite them are also congruent. So angle DEF is congruent to angle DHG. And that's because if two sides congruent, then the angles opposite them are also congruent. So I'm going to go ahead and mark this. Well, hopefully now you can see that we can actually prove these triangles congruent already by SAS. So triangle DEF is congruent to triangle DHG by SAS. So one side, and then we proved that the angles were congruent, and then the other side. And then lastly, we can prove that DF is congruent to DG by CPCTC. Okay, so again, that the whole theorem of this chapter is proving triangles congruent. Okay, I kind of brought this up earlier, that if equiangular, then the triangle, or excuse me, if equilateral, then the triangle is equiangular. And the shorthand version, again, is with diagrams. So if equilateral, then equiangular. And then we can say the converse. If equiangular triangle, then equilateral. And the shorthand version is if all three angles are congruent, then all three sides are congruent. All right. That's it for this slide. Okay, now let's take a look at the last slide. We're actually going to skip this proof entirely. It's a pretty lengthy proof. Instead, we're just going to go down to angle side relationships. So the smallest side is opposite the smallest angle. And then the same can be true about the largest side is opposite the largest angle. Okay, so if we look at this diagram, the second one, notice that this is going to be the smallest side. So across from it is going to be the smallest angle. Well, looking at our numbers, the smallest is 40 degrees. Okay. Then the biggest side length is 8. So that means across from 8 is going to be the biggest angle, so 80 degrees. And then that leaves 60 degrees. Okay. In the next example, it says to list the sides from largest to smallest. So before we do that, we actually need to find the missing angle. Well, remember that a triangle adds up to 180. So if you do 180 minus 48 minus 87, that gets you 45 degrees. Okay. So the smallest side is going to be across from the largest side is going to be across from the largest angle. Why am I doing largest first? Because it wants largest to smallest. So across from this is going to be segment DV. Then 48 degrees is the next angle. So across from that is BE. And then finally, 45 degrees is the smallest. So across from that is DE. So we will finish up that one proof in class. Otherwise, we are done. As always, thank you for watching and have a splendid day.